Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On, and in this tutorial video, I'll be going through these redox titrations. So a redox titration is something that involves a change in oxidation number. We're going to be using this purple color solution, which is actually potassium manganate 7. It's KMnO4. The manganese is in a +7 oxidation number. This one looks a bit light in color. In reality, it's supposed to be a lot darker. It's just a bit light here because I've made it to be quite diluted, so it's not very concentrated at all. We're going to use that as an oxidizing agent. So acidified KMnO4 is our oxidizing agent. And what I have here is just this really light color, looks a bit colorless, but it's supposed to be very pale green as a result of these iron 2 in solutions. And this iron 2 was actually made up in acid, because if you make up iron 2 plus aqueous in just water, it is very prone to oxidation in atmospheric oxygen. So that's why iron 2 plus is always made up in dilute sulfuric acid, and to some extent that will actually acidify the KMnO4 and allow you to do this redox titration, because without the H plus, your redox equation will not work at all. So this reaction, this redox titration is self-indicating, because we already have a color reagent, and it will turn from purple to colorless with kind of like pale pink, because one extra drop of this from the burette is going to not going to go anywhere, because it will not be turned into Mn2 plus if there is no more iron 2 plus in the conical flask. We're just going to start off by washing our conical flask. So I'm just rinsing it with some distilled water. It really doesn't matter if your conical flask is a bit wet, because the amount of water in there is not going to affect the mole of the iron 2 plus that you're going to pipette out, which is 25 ml of it. So this is a 25 ml, 25 cm pipette. It's not going to affect the mole of the stuff that we pipette out with a little bit of water left. So we're just going to rinse it with distilled water. Similarly, after your first or your second titration, you can just throw away your contents, rinse with tap water, and then just rinse with some distilled water. It shouldn't affect your result at all. We are not sure what happened the last time someone used this in the lab, so technically speaking, if you are doing this as part of school experiment, you should wash your burette and pipette with distilled water first, but then make sure you also rinse it with the solution that you're going to put in there later on before you use it for the first time, okay? Because you don't want any distilled water left in there. So I'm just going to, put some distilled water through the top inlet there. And what we see here is I gotta pass out some water into this bulb here, and then I just roll it around so that I'm just quickly rinsing out my pipette with distilled water. Similarly with the burette, so tap close a little bit first, and then put some distilled water in there. And you don't need a lot, we're just washing out. Remember to actually open the tap and wash the bottom with the distilled water into the sink, because I don't want the water to spill all over the floor. So I'm just going to roll it around. You can see a little bit of liquid distilled water, and then I will just roll it around as I pour it into the sink. And I've got a bit of distilled water left in there from where I opened the tap just now. I'm just going to open the tap upside down, and it is now empty. So I've gotten rid of the distilled water. So given P or Q, doesn't matter, you read the question. So in this question that I'm going to do, this KMnO4 goes in the burette. So it means that I have to rinse my burette with the solution that I'm going to fill it in. So I just put a little bit of it, for rinsing. We have an immediate issue before you start your titration. This one is colored. It becomes a problem if this is colorless and you forget to actually open the tap to allow this to pass through before you actually do your rough or your exact titration. So open the tap into the sink, like that, and this is color. You can see I already opened the tap, and I have this solution filling in this region at the bottom, so it will be reading accurately. We want to rinse the burette with the solution that we are filling it in, so I'm just rolling it around and just throwing it in the sink here. I have also washed the bottom bit there already, so I'm just going to pour it out. So this has been washed with the purple KMnO4, including the bottom bit, so I can be sure that I can fill in my burette. So you don't necessarily have to start from 0.00. or you do 1 decimal place for O-level, IGCSE level, or GCSE level chemistry. I have failed just above 0. So this one is quite light purple, and you could see in reality you could get something a lot more concentrated, and it becomes really difficult to read. Whenever you have KMnO4 redox titration, you always read above the meniscus, because when it's really dark looking, it's an international standard. Everyone knows to just read it above the meniscus, not just because it is light and you can read here. I want to clarify that we should read above the meniscus when we are dealing with this titration involving this purple solution here. I haven't opened the tab because right after I wash it, I haven't opened the tab yet. So I need to open the tab to allow the KMnO4 to fill in the bottom before I do my first reading. So I'll just get a white background, and hopefully you should be able to read this. What does this one read to? Well, you can read it and I can read it afterwards. So make sure you're reading above the meniscus. So this one read to me above the meniscus as 0.5 cm cube. So hopefully you can see that above the meniscus, 0.5 cm cube. So you have 0 on top, 1 at the bottom. So you read from top to bottom. Only because this is a darker color solution and we can't really see when it's much darker, we always read it above the meniscus. There's 0.5 cm cube. Alright. There's my initial volume here. I should really have my question paper, which will have all the details. I will have a titration number. So I'm just setting up my table. I have my final volume from the burette reading, and then stroke cm cube, something like that. Okay, so of course you're given the table in exam, but if you are an A-level student or going beyond the 14 to 16 years of curriculum, you should be expected to come up with your own table because you have done it your entire life. So you have initial volume. Initial means at the very beginning. So initial volume and then stroke cm cube, and then you have your title volume, or your volume P or volume of Q or whatever solution that you have in the burette, the volume of that burette stuff being used. I've just written down as a title volume, TITRE, and then make sure you have the unit so we don't have to write down cm cube in every single reading we have in the table. And then we have our best title, then we are going to do a tick on it. And of course, you should set up the table very nicely. Our first one should always be our rough titration, and then you should do at least minimum 2 exact titles. In a real practical, you want to be as exact as possible. So yes, you're allowed an error margin of plus minus 0.2 cm cube for O-level, IGCSE and GCSE level chemistry, because all your burette readings have to be to 1 decimal place. Just now, my initial volume was 0.5 cm cube. So make sure you fill in the correct positions in the table where you say initial volume, so there's 0.5 cm cube there. We don't need to put down the unit because the unit was already in the label, in the heading, and it has to be 1 decimal place for all the burette reading. So this thing is self-indicating because it's going to go from purple, and then I have to pipette out my iron 2+. So I haven't washed or rinsed my pipette with the solution yet. So this is my iron 2+. I'm just going to take out a little bit of it and rinse my pipette. So I don't fill up my pipette, but I just take out a little bit. Then I take out my pipette filler. Then I just roll it around, and I'm washing the side of the bulb with the iron 2+, and then I let it flow out from the very top. So that was just rinsing the pipette with the solution that I'm going to use, and I think I'm ready to actually, suck out the 25 cm cube of the iron 2+. So pipette filler, put it in there, and then you press the button S here. So the S there refers to sucking out. After you press the A to, inflate some A, and then you can get the iron 2+ getting sucked out. I always find it slightly faster to do it at an angle. I nearly overshoot it, but anyway, it doesn't matter. This is way above 25 mil, so I need to adjust this. This solution is colorless, well, kind of like very pale green in color. So we are reading below the meniscus. So hopefully you can see that below the meniscus, this is 25 mil. I think it's gone down a little bit, but since my first one is a rough titration, it shouldn't matter that much. So eye level below the meniscus, okay? I think it's gone down even more. I better suck out a bit more. Okay, I think this is pretty much alright. So that's 25 mil. I'm ready to do my first titration. Okay, 25 cm3. So press the E button and then slowly roll out the pipette filler, and then your solution will go down into the conical flask. So it's best to do titration while standing up. It's not really good to do titration while sitting down, okay? So at the very end, you're left with like a couple of drops at the end of the pipette. So you tilt it sideways, and then 1, 2, 3, 4, 5. That should get rid of the last drop of solution left in the pipette. Okay. Which one I guess, alright. So my initial titer, so 0.5 cm3, so that's my initial volume. Let's have a look at the color change. So we're going to do a rough titration here. Rough titration means we don't care so much what the actual reading is, because if you don't know roughly where it ends, then you're not going to be able to work out the exact titer. By right, you should have a white tile at the bottom, and that should help you to see the color change better. So as I already recorded the initial volume, I'm ready to just open the tab fully. As you can see, it remains kind of like kind of colorless as well, because there is still a lot of iron 2 plus left in there. The iron 2 plus get converted to iron 3 plus in solutions, which is also very pale, kind of pale yellow. But because this is a very diluted solution, it doesn't look that colored at all. But when there is no more iron 2 plus, when everything has been converted to iron 3 plus, then extra drop of these is going to make the KMnO4 minus, the one that gives you responsible for the purple color, to remain in there unreacted, and therefore you will get a permanent pale pink or purple depending on how much you have. So we're just going to continue, and you still are colorless. You see there's no color change at all, but we're just going to stop when it changes color. Okay, so getting there, I think this is about it. Okay, so this rough titer, I wasn't being drop by drop. I wasn't doing it drop by drop because I'm doing a rough titration. As you can see, the color now, it is colored. It is colored, okay? Hopefully you can see it is colored. In comparison with this original solution, which was not colored. So we can be sure that this has just turned, but this can never be your exact titer. This is your rough titer. If I read the reading first, what do I have? I'm reading above the meniscus because this is supposed to be a dark color solution. And it's quite hard to read. We always read above the meniscus. That one is, and give me a minute. We read above the meniscus. 23.1 to 23.3 cm3. So for my rough titer, let's see if I lift this up a little bit, and hopefully you can see it against the white background. 23.3. Not too sure if that is clear. You read above the meniscus, so 23. Is that reading very well? Probably not. But you can see that 23 is on top, 24 is at the bottom. So you read from top to bottom. There is around 23.3 if I read above the meniscus. Okay. So 23.3. minus or take away 0.5, I get 22.8. This is my rough titration. I always make it a habit of doing a rough titration. Now I know 22.8 cm3 is my rough titration. I should probably fill out my burette because starting from 20 something is a bit dangerous and tricky. So let's start from a nice number. I've got it to around 14 point something there. I should remove a little bit to go to 15. Again, I'm reading above the meniscus. Don't mind that you can read this because it's quite light, but you should imagine a scenario where you're given a much more concentrated solution where this is a lot darker. So you need to read above the meniscus, and reading above the meniscus here give me 15. So I'm reading above the meniscus because this one is supposed to be a dark color KMnO4. Reading above the meniscus gives me 15.0 cm cube. So this is my initial volume, and I'm ready to do my first exact titer. So 15.0 for my exact titer. 15.0 plus 22.8, so give or take 23. 23 plus 15, 23 plus 15 is 38, but 38 would be in excess, but not a lot. So if I take away 2 cm cube or 3 cm cube, just now I didn't overshoot by a lot, so I'll just take away 2 cm cube, so 38, because 15 plus the rough, and then take away 2 cm cube, 38 minus 2, 36. So I will slow down. I will do drop by drop when I reach 36, but I will not do drop by drop from the very beginning because there will be a waste of time since I already did a rough titration. Anyway, let me just, we're supposed to do 2 exact, right? So I'll just head out what I need. So we need another 25 mil, 25 cm cube of this iron 2 plus here. So this one is going up quite quickly actually. So ejecting there. So this thing is a colorless or kind of pale green supposedly, but very dilute, so it's kind of like colorless. So you're reading below the meniscus, yeah? So be careful. You only read above the meniscus when it's a dark color solution, but you read below the meniscus if it is a colorless solution. So this is 25 mil, 25 cm cube. So if you can see that, below the meniscus, okay? Now this is my conical flask, which I rinsed with distilled water earlier. Should have been a bit more gentler, okay? So always be gentle with glass. So let gravity does its job, and when you reach the very, very end, only then you do the tapping. So let gravity does its job first. 1, 2, 3, 4, 5, 6, 7, okay. Now again, we don't need indicator, it's self-indicating. 15.0 is where I'm going to start this exact titer, plus the rough is going to give me roughly 38, but this is rough, so 38 cm cube final volume is going to be rough. I take away 2 cm cube, I should stop around 36 cm cube, then I do it drop by drop. And I know, okay, so 36 cm cube is around here. So 36 cm cube is around there. So you know, I'm not going to slow down, I will just let it flow full speed until it reaches 36, then I will slow down, okay? So when you reach 36, then I will stop, okay? I'm not wasting time that way because I roughly know where I'm fishing already. So it reached 36 already, so now it's 36. You see this thing is a bit, kind of like a bit colored now, but then we know this is still iron 2 plus in excess because the KMnO4 is still not in excess. If I swirl it, as you could see, it goes back to this color, which is not colored at all. Okay, so it's slightly darker now because of the iron 3 plus being formed in solution, but you don't have excess KMnO4 yet. Your end point is when you have a permanent pale pink, because one extra drop from here will not go away. One extra drop from here will remain there. You get a permanent pale pink color. So let's focus on that. Let me just zoom in on that. So I'll just do drop by drop now. So let's just focus on getting this thing drop by drop first. So you want your hand, you know you're around 2 cm away. So spend some time getting the control right. So I already got it drop by drop. And you want to swirl. You want to let it swirl. I'm right-handed, so I'm swirling the conical flask with my right hand, and my left hand is continuously on the tap, and then when it changes color, I stop. I don't do the reading yet. I don't care about the reading. Do not take your eye away. So just keep on swirling. This is quite slow actually. So just keep on swirling and swirling, hand on the tap, and when it changes color permanently, when you get a permanent pale pink, then stop. Okay, so it's getting there, I think. Is it there yet? Is it there yet? I think it's there already. I think it's just there. I think it is there. Just give me a minute, I've got one drop there. I think I've just reached the end point there, so that is kind of like pale pink. kind of like permanent pale pink. Not too sure how well the contrast is. It's very light because the solution is very dilute, but it is quite colored when you compare with this thing here. So this thing is supposed to be a little bit colored. This thing is totally colorless, kind of colorless. Okay, so if I put it on a white background, you can hopefully see the difference between the two. Okay, before I add one extra drop, I should take the reading first, just to be safe, just so that I have a record of what is going on. I read above the meniscus. This one is 36.5. 36.5 if I read above the meniscus. You read first. Later on, we can decide on whether we're going to use it or not. Okay, so that is 36.5 if I read above the meniscus. I don't think that is eye level actually. So hopefully that is eye level now. So 36 and then 37 at the bottom. You read above the meniscus. So 36.5 cm cube there. So 36.5, and that should give me 21.5 for my exact titer. What I'm going to do is I'm just going to add one extra drop and see what happens. So let's add one extra drop, two extra drop, and see what happens. It's quite light, yeah. It's really light, but hopefully you can see that it's getting a little bit more pale pink now. This is a permanent pale pink or permanent pale pink because this is supposed to be purple. When you only have one extra drop, it's not going to be purple. It's going to be a little bit pale pink as a result of it. So I'm pretty sure what I've gotten previously was quite accurate already, but this one is just 36.7. So this is 36.7. So I'm going to put it at an angle a little bit. So 36.7 there. So just now I got 36.5, 36.7. So still pretty close. I'm just going to take note of it somewhere, just so that when I do my exact titration later on, then I can think about what is going on. So that was my second one. So it was 21.5. Let's do a third titration, which is going to be our second exact one. So I fill out my burette first. And I think I'm going to start. I'm going to start from an easier number. So that is 17.0. So that is 17.0. So let me just make this upright. So 17.0 there. So reading above the meniscus, 17.0 cm cube. Alright, so 17.0 is where I'm going to start. I have run out of conical flask, so I will just put this away. Now actually I'm going to keep this. This was in larger access. I'm going to throw it away. Rinse it with some tap water. So after you rinse with tap water, I'm just going to rinse it with some distilled water. And then throw it away. I rinse a second time with distilled water. A little bit of distilled water left in there will not affect your titration volume because the mole of the stuff that you pipette out is unaffected by the amount of water left in the conical flask, and therefore it will not affect your burette titer at all. So let me just zoom that out a little bit. Nope, I don't need to zoom out. So this is my pipette there. I'm just going to eject out here. We read below the meniscus because this is not a colored reagent. So below the meniscus you can see, I think it got a bit of air bubble, but I think you should probably check a bit more, suck a bit more. That should do the job, I believe. So there's 25 ml there, 25 cm cube from this 25 ml pipette. So eject it out into the chemical flask. We're ready for our second exact titration. You're doing an actual practical. You want your exact titer to be almost identical, as identical as possible to the actual value. Okay. So you want it to be like what just now? 21.5 was my exact titer. So 21.5 was my exact titer plus my 17.0. I don't have a calculator with me, but I can do this manually. That's 5, 8. So I should get 38.5 cm cubed as my exact titer. But I don't want to only slow down to 38.5. I want to slow down maybe at 37, and then I can do drop by drop. Okay? Because I know I already taken away like 1 cm cube there. So I was supposed to end out at 38.5 with the exact titer, but I will stop when I reach 37 degrees Celsius. Not degrees Celsius, 37 cm cube. I will stop, and then I will do it drop by drop. Okay. So here you see it going a little bit pale pink. Let me just bring it around closer, and then you can see what's going on. You can see it going a bit pale pink there, but then we can swirl it around, and you can see the pale pink color disappears. You want it to be a permanent pale pink with 1 extra drop. So I'm just going to, that was what we're supposed to get, like permanent pale pink color. But then this is what we have at the moment, which is kind of like color of the iron 2 plus, which is like kind of colorless, isn't it? Okay. Anyway, so let's get your drop by drop done first. And then I'm just going to swirl. I'm right-handed, so I swirl on my right, and my left is on the tab. I don't look at the volume. I never look at the volume for exact titer. I just eye focus as I swirl. My eye is focused on when it changes color. So 1 extra drop will give me a permanent pale pink color. I think it's getting there, really close. This is our exact titer. We don't want to waste time. We don't want to waste time to do 1000 exact titration. I think it's just about changing color with the next drop, maybe. It's very, very light, isn't it? Come on. Come on. Yeah. I don't want to risk it. Has it changed? I probably need 1 extra drop. I think it has slightly changed because it's kind of like getting pale pink now. Okay, maybe 1 extra drop, but this is... No, I think it has changed. It has changed. Not too sure how clear it is, but 1 is supposed to be the original colorless, and this is a bit pale pink. This is a bit pale pink there. It's probably better on the contrast there. But let me just read the reading first, okay? Because that's important. If I read above the meniscus, there is 38.6. Read above the meniscus there is 38.6. And again, there's some sort of margin of error, right? If you don't think the color is that obvious, then you can go a bit further. 38.6, not too sure how well that will read. So read above the meniscus, so 38.6 there. 38.6, yep, that is what my reading is. 38.6, okay. So what do I have? 38.6 minus, so 1 decimal place throughout, 38.6 minus 17.0, I get 21.6, and they are within the 21.5 that I obtained previously. But yeah, I mean, these two really light color, but in reality, in the real exam, perhaps when you have more concentrated KMnO4, the color will be a lot more obvious. Okay, if you are not too satisfied with this color, you can of course add 1 extra drop and see what happens. So I'm just going to add 1 extra drop to this. 1 extra drop is probably like 0.05 cm cube. Oops, I've added 2 extra drops, and you can see the pale pink color a bit better now. So it's gone a bit darker. So the contrast is not helping us that well, to be honest. So that is still 38.8. So even 38.8 is going to give you 21.8, but that is beyond what is acceptable already. So it's really hard to tell, right? Which one is more exact, which one is not exact. But based on what I have seen, I could see the color change because I have my colorless solutions, well, nearly colorless solution to begin with. And then when it changes color, give me a permanent pale pink, that is when I stop. So I think my 21.5, my 21.6 is perfectly acceptable as my best title, which I'm gonna put a tick on it. And when I do my averaging, I have to show my working average 21.5 plus 21.6. I use a bracket because a lot of students, they don't use bracket and then they end up calculating the wrong stuff in the calculator. And what is important is I have 2 readings, so when I average, I divide by 2. If I have 3 best reading, if I have 3 ticks, all of them, they are within plus minus 0.2 cm cube for your O level, GCSE level, or IGCSE level titrations. You know that plus minus 0.2 cm cube is the maximum accepted error margin. But of course, in the real titration, you want your titer to be as exact as possible then. So you do that in a calculator, you get 21.55, and that will be actually incorrect because you are averaging up your titer. You have to give it to 1 decimal place. This is for the IGCSE, GCSE, or all level standards because all your burette titer has to be to 1 decimal place, including what you average out with your calculator. Okay, so thank you for watching. I'll see you in the next tutorial video, and this video should link very well with the practical questions that I have given you if you are my student in the school that I'm teaching at. Okay, see you in the next tutorial video. Don't forget, click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry, that's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. Thank you for watching.